To do well in mathematics, we need to have good building blocks. My name is Dr. Yap Banha, and today we are going to look at another building block for the topic of percentage. Given some information, say in a paragraph, in a story, perhaps a baker bakes two kinds of cupcakes, lemon cupcakes and banana cupcakes. And we might know that of the 50 cupcakes that the baker bakes, 40 of them are banana ones and 10 of them are lemon cupcakes. Given some information like that, are you able to say what fraction of the 50 cupcakes are lemon cupcakes? And hence, how many percent of the cupcakes are lemon cupcakes? That is one building block in this topic of percentage. The information might come in a story form, but sometimes we also get diagrams. Diagrams like that. We might be given a diagram, a figure, and parts of it might be shaded. And they would ask us, how many percent of the figure is shaded? In fact, all they're asking us is what fraction of the figure is shaded. But in this case, we want to give the answer as a fraction with denominator 100. In other words, in percent. So the information can come in a diagram. The information can also come in the form of graphs. For example, a pie chart, or in other instances, a bar graph, a picture graph, and any other kinds of graph. And in this case, we are told that these are the different types of storybooks in a small library. And maybe of the books in that library, some of them are in English, some of them are in Thai, some of them are in Chinese languages, and they might want us to figure out how many percent of the books in that small library is in the English language. So are you able to say 60 out of the books that's in the library? So what fraction of the books are in English? Which is just another way of asking you, how many percent of the books in the library is in English? Given some information in a graph, in a diagram, in a word problem, are you able to say what percent of the books, for example, are in the English language? Let's practice to become good at this building block. So we have a story. A baker bakes 50 cupcakes. 10 of them are lemon cupcakes and 40 of them are banana cupcakes. How many percent of the cupcakes are lemon cupcakes? How many percent of the cupcakes are banana cupcakes? We can show the information on a bar model. So we do know that there are 10 lemon cupcakes and 40 banana cupcakes. And the total number of cupcakes we have, 50. Are we able to tell what fraction of the cupcakes are lemon cupcakes, which is just another way to say what percent of the cupcakes are lemon cupcakes. Finding percentage is actually just finding fraction. Just that we want the fraction to have denominator of 100. So let's see. How many out of 50 are lemon cupcakes? Do we know? That's right. This is a fraction of the 50 cupcakes that are lemon cupcakes. It's 1/5, isn't it? But we want to have the fraction with denominator 100. Are you able to very quickly see what fraction is equivalent to this fraction? You are right. It's 20%. 20 hundredths. 1/5 is also 20 hundredths. So we will say 20% of the cupcakes are lemon cupcakes. What about the banana cupcakes? There are 40 of them out of the 50 cupcakes. Are you able to write a fraction to show the fraction of cupcakes that are banana cupcakes? Can you write it down? Did you get this? Is this the correct fraction? But we want to write a fraction to have denominator 100. Are you able to write this fraction, which is 4/5, in percent? Are you able to write the 50ths as hundreds? You are right. 40 50ths or 4/5 is also 80%. So 80% of the cupcakes are banana cupcakes. Perhaps another way of doing it. If we know that 10 cupcakes is actually 20% of all the cupcakes, are we able to easily figure out 40 cupcakes would be how many percent? If 10 is 20%, how about 20 cupcakes? How many percent would that be? And if you know 20 cupcakes is so many percent, are you able to figure out 40 cupcakes is actually how many percent? That's another way to figure out the answer. Are you able to do that? Let's check. 10 cupcakes, 20%. 20 cupcakes, 40%. So 40 cupcakes, 80%. You are right. In any case, 20% and 80% make 100%, which is really all the cupcakes that the baker baked. What if we have another story? There are 200 people in a hall, and 70 of them are adults. How many percent of the people in the hall are adults? Are you able to see how to write a fraction to show the number of adults? Can you write it down? So this is a fraction of the people in the hall who are adults. But the denominator is 200. what can we do to get the denominator to become 100? The numerator is 70. You are right. It's 35%. 35 hundredths. So we say that 35% of the people in the hall are adults. Perhaps we try in another way. 200 people in the hall. Are you able to figure out 10% easily? That's right. 10% would be 20 people. So we do know that 20 people represents 10%. If we know 20 people represents 10%, can we figure out 70 people represents how many percent? Can we try? So, 10% represents 20 people. So 20 people is really 10% of the group. So 60 people would be how many percent? 20 represents 10%. 40 represents 20%. So 60 represents 30%. And if 20 represents 10%, how about 10 people? 10 people would be how many percent? You are right. If 20 represents 10%, 10 would represent 5%. So, if we know all that, if we know that 20 people is really 10%, 40 people represent 20%, 60 people represents 30%, and 10 people represents 5%. Can you see? 70 people would be how many percent of the group? Just get it from here, isn't it? Which is 35%. I suppose that is another way. Let's practice another question. So sometimes the information given to us is in a diagram. They might ask us, for this triangle, how many percent of it is shaded blue? For the other triangle, how many percent of it is shaded blue? For the smaller triangle, can you see what fraction of it is shaded blue? 1/4, isn't it? So the question is, 1/4 is how many percent? In this building block, you should be able to write some fractions like 1/4 as a percent. Are you able to write 1/4 as a percent? How many percent is 1/4? 25%, isn't it? Because 4 25s make 100. So 4 25% make 100%. So 1/4 is really 25%. What about the other diagram, the bigger triangle? The question could be, find the percentage of the triangle that is shaded blue. So the question is really just what fraction of it is shaded blue. Here we can see that the triangle is made up of 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 units. And of the 9 units, 9 small triangles, how many are shaded blue? 6 are shaded blue. So we can say that 6/9 of the triangle is shaded blue. The question is, 6/9 is how many percent? some fractions are more difficult to write as a percent. For example, in this case, I do know that 6/9 is really 2/3. But to write it in percent, it will take me a little bit more time. Or perhaps I might need a calculator. You can try it, use a calculator and see whether or not you end up with 66 and 2/3%. So some fractions like this one are not so easy to write as a percent. We might also get information given to us in the form of a graph, like a pie chart. Perhaps we are told that in a class, half the children walk to school and 1/5 of them come in cars. So, how many percent of the children walk to school? We can see the fraction is half. So the question is half is how many percent? Are we able to very quickly say that this is really, you are right, 50%. So we say that 50% of the children walk to school. How about 1/5? Are you able to say 1/5 is how many percent? So one important building block in percentage is that you are able to say this fraction is how many percent. The pie chart shows the number of books in a small library that are in different languages. 60 in English, 46 in Thai, and 94 in Chinese. And these are all the books in that small library. How many percent of the books in a small library are in English language? Are you able to see the fraction? 60 out of, we need to find the total of this. So 94 and 46, 6 move over, we get 100, 140, 200. So the total number of books, there are 200. Are you able to see the fraction of the books in a library that are in English language? You are right. It is that fraction, isn't it? How many out of 200? 60 out of 200. Are you able to write that in percent? Why don't you try? 60 out of 200. That is right. It's 30%, isn't it? What about those in the other languages? How many percent of the books are in Thai? You're able to write down the fraction, isn't it? But can you also work it out in percent? Did you get this? 23%? How about the one in Chinese language? How many percent of the books are in Chinese language? Are you able to work out that one? Did you get that fraction? So this fraction of the books in a library are in Chinese. But can you write it down with denominator 100? Can you write it down as a percent? Do you see the calculation you need to do? Did you get that one? 47%, isn't it? It's your turn now. Let us do two activities to help us master this building block. The first activity. Are you able to, given a fraction with a certain denominator, able to say what percent is it? For example, if I give you 91 hundredths, can you say that in percentage? What about a fraction with denominator 10? If I say 9/10, are you able to tell me that in percentage? What about this fraction? If I give you 12/25, can you say that in percent? How many percent is 12/25? And fractions like that. If I give you 11/20, can you write that down as a percentage? So in the first activity, can you make up some fractions that we can write as a percentage easily without too much calculations? Do you think fractions like that with denominator 200, we can write it down as a percent easily? For example, 198 as a numerator. So in this activity, you want to make fractions that are quite easy for us to write as a percent. Would half be easy to write as a percent? What about other fractions, like 1/4? Would that be easy to write as a percent? A second activity to help us master this building block. Can you be the teacher and you make up numbers? For example, what if you say that in a group of 5 children, one of them is a boy? How many percent of the children are boys? So can you put in numbers here? For example, if you put in 1 here and 4 here, can people tell you how many percent is that 1? In other words, 1/5 is how many percent? So that is our second activity. Are you able to put in numbers into these two spaces so that people can tell you how many percent is that? So if I put 1 here and 4 here, I can say, well, that is 1/5 of everything. And 1/5 is 20%. What about if I put 2 here and 3 here? Would that be easy to do? What about 3 here and 7 here? Would that be easy to do? What about 10 here and 90 here? Would that be easy to do? In a second activity, to master this building block, why don't you be the teacher and you make up numbers to put into these two spaces and you let other people figure out how many percent of the group is that. If you're on your own, why don't you make about 5 to 10 such questions and then write down the answers, and when you have a chance to meet your teacher, you can ask your teacher to try those questions. If you're in a class, why don't you let your friends try your questions and you check whether they're right or wrong? And if you're at home, why don't you let your parents try to solve your problem? We have learned, we have practiced, and hopefully we have mastered this building block. In this building block, given a situation, perhaps in words, in a story, in a diagram, in a picture, in graphs. Given any situation, can we write down the fraction about something that we are interested in and afterwards rewrite that as a percent? There are 10 cubes. How many percent of the cubes are green? So this is a situation. Can we write down the fraction about the thing that we are interested in? Number of cubes that are green? 4/10. Can we rewrite that as a percent? 40%. So we say that 40% of the cubes are green. See you next time in another building block.